Nikola Tesla. The name alone sparks images of lightning bolts, mad genius, and impossible inventions. But here's what most people miss. Tesla wasn't a magician. He was an engineer. A brilliant one, yes, but still bound by the same laws of physics as everyone else. The gap between the legend and the reality is enormous. Pop culture turned him into a mythical figure who could bend electricity to his will, who saw the future in his dreams. The truth? Tesla was a methodical inventor who filled notebooks with calculations, filed patents, and built working prototypes. He wasn't channeling cosmic energy, he was solving problems. But here's the interesting part. Dozens of his patented ideas never made it past the drawing board. Not because they were impossible, not because they violated physics, but because they couldn't be built with the technology, infrastructure, and economic realities of his time. This isn't a video about Tesla the myth. This is about the inventions he designed, calculated, and documented but never constructed. Some were too expensive. Some were too dangerous. Some threatened the business models of the most powerful men of his era. Some simply arrived a century too early. We're going to look at the blueprints, the patents, and the prototypes that stayed on paper. Not the fantasies, the real engineering work that never became real machines. The detailed schematics that gathered dust in filing cabinets. Because understanding what Tesla couldn't build tells us more about him than what he did build. Let's start with the most famous one, wireless power transmission. In 1901, Tesla began construction on what would become his most ambitious project, Wardenclyffe Tower, a 187-foot structure on Long Island, designed to transmit electrical power through the Earth itself. No wires, no infrastructure, just raw energy beamed across continents. This wasn't science fiction. Tesla had already demonstrated wireless power transmission on a small scale. He could light up fluorescent bulbs from across a room. He'd calculated the resonant frequency of the Earth's ionosphere. His patents contained detailed schematics for tuned circuits that could send and receive power through electromagnetic resonance. The theory was sound. Tesla understood that the Earth itself could act as a conductor. By creating standing waves in the planet's electrical field, he believed he could establish nodes where receivers could extract power, anywhere on the globe. It was elegant. It was revolutionary. It was also completely impractical for 1901. Here's what worked. The basic physics. Resonant inductive coupling does allow wireless energy transfer. We use it today in phone chargers and electric toothbrushes. Tesla wasn't wrong about the principle. Here's what didn't work. Everything else. First, the efficiency problem. Power transmitted through the Earth's electromagnetic field loses energy with every meter traveled. At the scale Tesla envisioned, global transmission losses would be catastrophic. You'd need to pump in megawatts to get kilowatts out on the other side. Second, the control problem. Unlike a wire that directs current from point A to point B, Tesla's system would broadcast energy in all directions. There was no way to meter it, no way to bill for it, no way to prevent someone from tapping into the field and taking power for free. Third, infrastructure. The system required a network of massive towers, each one as expensive as Wardenclyffe. Building just one nearly bankrupted Tesla. Building enough to create a functional global grid? Impossible. Fourth, interference. Every electronic device on Earth would become a receiver, whether you wanted it to or not. The electromagnetic pollution would render most sensitive equipment useless. Tesla knew some of these problems. His notebooks show him wrestling with efficiency calculations. But he believed scale would solve them. Build bigger towers. Pump in more power. Tune the resonance more precisely. He was wrong. Not about the physics, about the economics and the engineering realities of his era. Wardenclyffe Tower was demolished in 1917. The copper was sold for scrap during World War I. The dream of wireless power died with it. For a century, at least. But Wardenclyffe wasn't just about power. Tesla had a bigger vision, one that makes him look almost prophetic when you read his writings today. He imagined a global network that could transmit not just electricity, but information, data, signals, a worldwide system where anyone could send messages instantly to anyone else, anywhere on the planet. He called it the world system. Sound familiar? In 1900, Tesla wrote, "It will soon be possible to transmit wireless messages around the world, so simply that any individual can carry and operate his own apparatus." He was describing smartphones. In 1900, his vision went further. The same towers that transmitted power would carry voice, images, and precise time signals. You could use them for navigation, knowing your exact position anywhere on Earth by triangulating signals from multiple towers. He was describing GPS 70 years before satellites. Tesla saw the future with startling clarity. He understood that information and energy could travel through the same infrastructure, that wireless communication could be ubiquitous, that the world could be connected in real time. So why didn't it happen? Economics, pure and simple. Tesla's system had a fatal flaw. It was designed to be free, or at least uncontrolled. Power and data would broadcast through the atmosphere, available to anyone with the right receiver. No meters, no subscription fees, no way to prevent access. For Tesla, this was the point. He genuinely believed in free energy for all of humanity. He thought it was a moral imperative. For investors, it was a nightmare. J.P. Morgan, who had initially funded Wardenclyffe, demanded to know, "How do we charge people for this?" Tesla couldn't give him a satisfactory answer. Morgan pulled his funding in 1903. The tower would never be completed. Other investors had the same reaction. Why build a system where anyone could tap into the signal for free? Where was the business model? How would they recoup their investment? Tesla's refusal to compromise on this point killed the project. He could have designed metering systems. He could have built in access controls. But he wouldn't. To him, that would defeat the entire purpose. So the world system stayed on paper. The infrastructure was never built. The patents expired and used. But the idea didn't die. It just waited. Decades later, when radio, television, and eventually the internet emerged, they followed the model Tesla had outlined with one crucial difference. Someone figured out how to charge for it. Tesla's vision was right. His timing was right. His technology was mostly right. His business model was impossible. Now we enter darker territory. In 1934, at age 78, Tesla announced to the press that he had designed a weapon that would end all wars. He called it Teleforce, though newspapers immediately dubbed it the death ray. Tesla claimed it could project a concentrated beam of particles at tremendous velocity, enough to bring down entire fleets of aircraft at a distance of 250 miles. He said it could destroy ground troops, annihilate tanks, and create an impenetrable defensive shield around any nation that possessed it. This wasn't Tesla rambling in his old age. He produced technical documents. He approached multiple governments, the United States, the United Kingdom, the Soviet Union, Yugoslavia. He claimed the weapon was fully designed and could be built immediately for $2 million. No one took him up on the offer. Here's what we know from Tesla's papers. The device would use a massive Van de Graaff generator to accelerate microscopic tungsten or mercury pellets to extremely high velocities. These would be fired in a focused beam, delivering kinetic energy on target. Not exactly a ray in the science fiction sense, more like a particle accelerator weaponized. The physics, partially sound. Particle accelerators existed. Kinetic projectiles can deliver enormous destructive force. The principle wasn't impossible. The engineering, completely impractical for the 1930s. First problem, power requirements. To accelerate particles to the velocities Tesla described would require electrical generation on a scale that didn't exist. We're talking megawatts of sustained power, far beyond what any mobile platform could provide. Second problem, beam coherence. Keeping a stream of charged particles focused over hundreds of miles through atmosphere? atmospheric interference, electromagnetic dispersion, and simple divergence would scatter the beam long before it reached its target. Third problem, targeting. How do you aim a weapon with that kind of range when you can't see your target? Radar was still experimental in 1934. Fire control systems couldn't handle those distances. Fourth problem, efficiency. The energy required to destroy a target 250 miles away would vastly exceed the energy needed to simply use conventional weapons at shorter range. But here's the interesting part. Governments did examine Tesla's proposal. The U.S. War Department reviewed his documents after his death in 1943. Their conclusion? Insufficient technical detail to evaluate. The Soviets apparently conducted some experiments based on his ideas. Nothing came of it. Was Tesla deliberately vague because the technology was incomplete? Or was he trying to keep the critical details secret? We'll never know. What we do know is this. Some of Tesla's designs were kept classified for years after his death. Not because they worked, but because governments wanted to make sure no one else could make them work. The death ray was never built. But the fact that multiple world powers took it seriously enough to classify the documents tells you something. Tesla's reputation was such that even his most outlandish claims couldn't be dismissed outright. Decades later, directed energy weapons did emerge: lasers, particle beams, electromagnetic pulse devices. They faced many of the same limitations Tesla encountered. High power requirements, atmospheric interference, limited range. Even with modern technology, weaponized energy beams remain largely experimental. Tesla was right about the concept. But once again, he was working with technology that wouldn't exist for another 50 years, and even then, barely. There's a famous story about Tesla. He attached a small mechanical oscillator to a steel beam in his New York laboratory and nearly brought down the building. Neighbors reported walls shaking, windows rattling, ground trembling. Tesla had to destroy the device with a sledgehammer to stop it. The story has been embellished, but the core is true. Tesla did build mechanical oscillators. He did experiment with resonance. And he understood something terrifying. Every structure has a natural frequency, and if you match it, you can shake it apart with surprisingly little energy. The principle is simple. Push a child on a swing with perfect timing and small pushes create large amplitudes. Do the same to a bridge or building, and you can induce catastrophic oscillations. Tesla's oscillators were pistons driven by compressed air or steam, tuned to specific frequencies. By adjusting frequency, he could find the resonant point of any structure. Once matched, oscillations amplified with each cycle. His patents describe devices from pocket-sized to industrial. He envisioned them for mining, demolition, surveying, even earthquake generation. Tesla claimed he could build one powerful enough to split the Earth in half. Was he exaggerating? Probably, but not by much. The physics checks out. Resonant amplification is real. The 1940 Tacoma Narrows Bridge collapse was caused by wind-induced resonance. Engineers now design specifically to avoid resonant frequencies. So why didn't Tesla's mechanical oscillators become standard tools? First, control. Once you start a resonant oscillation, stopping it isn't easy. Tesla discovered this when his lab shook uncontrollably. The oscillator might be small, but the forces it unleashes are not. Second, unpredictability. You can calculate resonant frequency of simple structures, but real-world buildings are complex. Multiple resonant modes, coupled systems, the mathematics becomes intractable. Third danger. An oscillator that demolishes buildings can't distinguish between targets. Collateral damage would be inevitable. Fourth, liability. Imagine the lawsuits, the regulations, trying to ensure technology that could accidentally trigger structural failures blocks away. Tesla built prototypes. He demonstrated the principle clearly. He filed detailed patents. But he never commercialized it. Neither did anyone else. The risks were too great, the control too uncertain. The devices exist in museums now, silent and harmless. The knowledge remains. Every civil engineer learns about resonance and structural frequencies. Tesla didn't invent resonance. He just understood it better than most and wasn't afraid to weaponize it. The world decided it was better left as a curiosity. Let's talk about money, because that's ultimately why most of Tesla's grand visions stayed on paper. Nikola Tesla was a brilliant engineer. He was a terrible businessman. The relationship that defined and doomed Tesla's projects was with J.P. Morgan, one of America's wealthiest financiers. Morgan funded Wardenclyffe Tower with $150,000 in 1901. Huge sum, but it came with expectations. Morgan wanted return on investment, exclusive rights, a product that could be sold, controlled, monetized. What he got was Tesla expanding scope, burning money, talking about free energy for the world. When Tesla admitted Wardenclyffe wasn't just wireless telegraphy, it was broadcasting free power, Morgan was done. He cut funding in 1903. Tesla never recovered financially. But Morgan wasn't the problem. The problem was Tesla's fundamental approach. Tesla wasn't interested in incremental improvements. He didn't want to build something, sell it, fund the next thing. He wanted to skip to the revolutionary endpoint, build the entire system at once, change everything immediately. This is not how you attract investors. Investors want milestones, proof of concept, a clear path from investment to profit. Tesla offered grand visions and asked them to trust it would work, eventually, if they kept funding. He also refused to compromise on his ideals. When investors suggested monetizing his wireless power, metering, subscriptions, controlled access, Tesla rejected them. He believed energy should be free for everyone. Noble? Absolutely. Practical? Not remotely. The wireless system would have required dozens of towers, each costing hundreds of thousands. The global network needed infrastructure on a scale that made transcontinental railroad look modest. And Tesla wanted to give it away. From a purely capitalist perspective, this was insane. Tesla also had a habit of chasing the next idea before finishing the current one. Inspiration would strike and his focus would shift. Investors hated this. They wanted deliverables, not promises. By 1943, Tesla died broke in a hotel room in debt, his ambitious projects abandoned decades earlier. Meanwhile, Edison, Westinghouse, Marconi became wealthy by taking practical approaches. The lesson isn't that Tesla was wrong. It's that being right isn't enough. You need funding, infrastructure, a business model, investors who believe not just in the technology, but in profiting from it. Tesla had the vision and genius. He even had working prototypes. What he didn't have was patience, flexibility, or business acumen to turn vision into reality. And so his greatest inventions stayed exactly where they started, on paper, in patents, in notebooks locked away. Here's the interesting part. Tesla was eventually proven right, just not in his lifetime. Wireless communication. Tesla demonstrated radio-controlled boats in 1898. Marconi gets credit for radio, but Tesla's patents came first. The Supreme Court ruled in Tesla's favor in 1943, the year he died. By then, Marconi had won the Nobel Prize. Remote control and automation. Tesla envisioned machines operating without human intervention, guided by wireless signals. Today, robotics, drones, autonomous systems. The principle, wireless control signals, is what Tesla demonstrated over a century ago. Wireless power transmission. Tesla's dream of beaming electricity through the air without wires seemed absurd in 1900. But modern inductive charging, the technology that powers your phone on a charging pad, is based on the same resonant coupling principles Tesla explored. It's limited in range compared to his vision, but the physics is identical. Global communication networks. Tesla described a system where anyone could send messages anywhere instantly. We call it the Internet. Different infrastructure, fiber and satellites instead of towers, but the concept is identical. Even GPS echoes Tesla's ideas. He proposed wireless towers broadcasting precise time signals for navigation. Modern GPS uses satellites, but the principle, triangulating position from synchronized transmitters, is similar. So why did it take so long? Materials. Tesla's era lacked semiconductors, transistors, integrated circuits, components that make modern wireless technology practical. He was building 21st century systems with 19th century tools. Infrastructure. Wireless communication needed critical mass of transmitters and receivers. Building incrementally, starting small, is how it happened. Tesla wanted it all at once. Economics. Successful technologies could be monetized at every development stage. Early radio made money. Each iteration funded the next. Tesla's all-or-nothing approach left no room for incremental profit. But give Tesla credit, he saw the destination. He understood where technology was headed. His error was thinking he could skip the journey and arrive there immediately. Most of his unrealized inventions weren't wrong. They were just early, sometimes a century early. So what's the real lesson here? It's not that Nikola Tesla was a failure. His inventions weren't impossible. It's that timing matters as much as brilliance. Sometimes more. Tesla understood the future. He saw technologies that wouldn't exist for decades. But understanding the destination doesn't mean you can skip the journey. You can't build the 20th floor before the first 19. Every technology requires prerequisites, materials, infrastructure, economics. Skip any and even brilliant designs stay theoretical. Wireless power, brilliant, but without efficient semiconductors and metering, it couldn't work at scale. Physics was fine. Reality wasn't. Directed energy weapons? Sound concept. But power requirements exceeded what platforms could generate. Even today, same limits. The global network? Tesla was right about everything except how to pay for it. He wanted to give it away. People with money wanted to charge. Guess who won? This is the engineer against the system. Tesla was brilliant at solving technical problems, terrible at navigating economic, political, social constraints. And those constraints matter as much as physics. There's another layer. Some ideas shouldn't be built. Tesla's oscillators could have been weaponized into earthquake generators. His death ray could have changed warfare in terrifying ways. Sometimes staying on paper is a feature, not a bug. But the deepest truth, his unrealized inventions weren't wasted. Those patents, notebooks, demonstrations, they inspired generations of engineers. The people who eventually built wireless communication, remote control, resonant power transfer all stood on Tesla's shoulders. His failures became foundations for others' successes. Tesla didn't lose. He was just early. And in engineering, being early and being wrong can look identical until enough time passes. Tesla worked decades ahead of the possible. History proved him right, just not in time for him to see it.